Okay, recorded. Okay, so for tutorial 4, we have a few questions related to single process and a few questions related to multiple processes. Anyone got any issue in understanding how the material balance or the mass balance work? Any question? Do you understand how it works? I think in the video I already gave a few example. And this mass balance is very important for you to understand because during your third year and final year, there will be one big project we call as a plant design project in which you need to design your own plant. Uh, I don't know. It depends to because every year we're going to change the project. Like your senior this year, they will focus on designing a factory for the production of decaffeinated coffee, decaffeinated coffee powder. And the other group, they will design a factory, a plant related to the production of protein hydrolysate from fish waste. Okay, so something related to food industry, but every year we change the topic, yeah, the product. So and when you are designing a factory or a mill, it should be consisted of the processing and the production from raw material up to becoming the powder, the product. So along the way to produce this product, there will be a lot of processes involved. And when the processes involved, you want to also know the mass balance between each processes and the overall processes. Not only the mass balance, but also the energy balance, which you will learn after coming back from the mid-semester break. So that's why it's very important for you to understand how the mass balance should be calculated so that during that big project you don't have any issue or any problem in doing the calculation for that. But in the same time, we have software nowadays in which during our final class, in the maybe in the week 13 or week 14, I'm going to show you software that we can use in order to do the mass balance for the overall production of a factory. Because for factory normally it's consisted of a long of line of processes, right? So the even the processes is bit complicated. The one that we do, the example based on our manual calculation is just based on three or four, maximum four processes. But for in the real industry, the process, the unit process involved might be more than 20 or even 50. Yeah, so we have the advanced software that we can use in order to do the calculation, but the basic, the fundamental calculation about this mass balance should be understand first before you use the software. The software will be shown, will be I will show the software later during our few final weeks before the final exam. And but before that, we need to do the manual calculation for the mass and energy balance. Okay. So for the mass and energy balance, for the mass balance, just some recap. Okay. Okay. So for the mass balance, we have the single process. Uh, what happened? Single and also multiple processes. Okay, when it's come to the multiple processes, it is the calculation is longer lah because we have to consider each processes in order for us to solve the mass balance. Okay, but in the same time, in order for us to do this calculation of the mass balance, we need to do a degree of freedom analysis. the degree of freedom analysis, or we just call it in short DOF. Okay. What is so important? Why it is so important for us to do the degree of freedom analysis? Anyone can share? Why? Why we need to start with the degree of freedom analysis? Big question here. Why? Anyone? Because it helps to know where to start our calculation. Good, Metusa. Okay, that's one thing. Yeah, because we want to know where to start the calculation. And the most important thing, whether the balance can be solved or not. Yeah, whether all the information is enough for us to do the calculation or not. Because if we don't get the degree of freedom analysis equals to 0, the balance cannot be solved. Yeah, as simple as that. And then if then later if when we have multiple processes, then we do the degree of freedom analysis in order for us to determine which to start first. Because we have maybe process A, process B, process C, process D, and the overall processes. So we need to do the degree of freedom analysis for each processes to see where to start. So need to also know how to do the degree of freedom analysis. Definitely this is something that I would ask in the test. Okay. Dah orang bocor dah ni. Ada hint, ada tips, okay. Please understand how to do the degree of freedom analysis because I keep facing the same thing every year. Most of the students fail to know how to do the degree of freedom analysis. They don't know how to do the degree of freedom analysis because they don't understand. Even I already included, yeah, Fatin. Ah, tak mute lah tu. Hold on for a second. Dah. Fatin. Okay. So, during the calculation for the degree of freedom analysis, you need to know how to do it because every year I face that so many students fail to do the calculation correctly because they don't understand. Even during the video that I provide to you, I already provide another video from the YouTube explaining details about degree of freedom analysis. So please just go and repeat the video and try to understand how to perform the degree of freedom analysis. Yeah, because that's very important for you to start with before you can even start doing the calculation with the mass balance because you want to know whether a process can be solved or not based on the degree of freedom analysis. Yeah, we want to make sure that the degree of freedom analysis should be 0 before we can solve any kind of problem. Okay, so we start with the first question for the single process because I'm keep highlighting a degree of freedom analysis. So the first question is about the degree of freedom analysis. Okay. So sample consisted of two components, X and Y. Okay. Perform a degree of freedom analysis for the process diagram below. Okay. So during when you want to solve any kind of problem related to mass balance, yeah, the most important thing is to make sure that you draw this diagram first, the process diagram. eh, the box here and the flow in, flow out, flow in, flow out, how many flow in, flow out, so that you're going to get you're going to get a clearer view about the whole process. And then you list down everything. I don't know what happened to this writing tab because this is, let me change to the other one because this is, it's okay. Okay, so when you already have this kind of if the question did not provide you with one, you need to draw. But if the question already provide you, then it's okay lah. But if the question did not provide you any uh process flow diagram like this, Oh. Oh, sekejap tak boleh tulis pula. Pakai mouse boleh, tapi pakai dispen dengan tab ni tak boleh pula. Aduh. Next week, do you have in other tests beside my subject?
Ada Doktor.
Ada. This week, how many subject that you got test? One only. So most of the tests will be next week. Ke?
Yes.
I thought all the lecturer already arranged so that the most of the tests will be this week. So that next week you're going to get an opportunity to go back to your hometown earlier. Tahu I tak change the ni. Tapi on Monday, do you have any test on Monday? No, right? Next Monday. I mean like during our subject test in the morning, do you have other tests in the afternoon ke?
Yes,
Ada.
Doktor.
Ada. Subjek
Ya.
apa?
Static.
Kenapa tak minta tukar? Statik siapa ajar?
Dr. Khairul Faiza.
Itulah. This is a lesson for you guys. Later, please discuss, because I know sometimes it's very hard for us to have two tests on the same day because we want to prepare. So just nego with the lecturer, okay? Because we as a lecturer too, we already did some harmonization of the courses every week for first year student like you, those who are teaching the first year student, we already kind of like stated what date on test that we're going to do. What date for test one, what date for test two. Normally we try to avoid ourselves from have this clash lah. Student will have two or three tests in one day. I think initially I don't know what is the arrangement with Dr. Khairul Faiza, but saya yang paling awal letakkan date tu so that every other lecturer should be aware lah. On 25th tu, I already are going to do my own test on that date. So the normal what arrangement is that if a lecturer already book to do a test on that particular date, the other lecturer that teach the same student, we try to avoid doing the test on the same date. But maybe Dr. Khairul Faiza or I don't know how the arrangement. Maybe she doesn't aware that I already booked to do the test on Monday. So it's up to you as a student to remind her because I already informed you that we're going to do the test very early, right? Like I already informed you in week 2, right? Week 2 or week 3? Week 2, I think. That I'm going to do in mula kan di Khamis. Lepas tu ada yang minta tukar. Minta hari Selasa katanya. Okay lah, it's okay. Saya layankan sebab saya fikir, I thought that nanti akan ada ni lah. Most of the lecture, even in fact, masa saya tengok dalam waktu arrangement pun, most of the lecture nak buat test hari week 5. So that's why I think, tak apalah, it's okay lah. Saya cepatkan sikit on Monday. But tak tahulah. But it's okay. What to do? And that one is online or physical? Boleh pun. Okay. With Dr. Khairul Faiza. Static, it is online, physical juga.
Physical.
Okay lah. So next time, okay, please arrange. Let the lecturer know. Say we still have some room for negotiation. For instance, like you already know that on Monday, my subject will have the test. Eh? So please discuss with Dr. Khairul Faiza saying, Dr. Khairul Faiza, can we change the date to other day because we have one test on this day. So we want to prepare to have more time to prepare. Something like that lah. Yeah. So this is a lesson for you. I know you are in your first year. So maybe takut-takut nak inform, but selalunya for senior they already they benda macam ni dia orang akan inform. Dia akan let the lecturer know as soon as possible. Because we are also flexible. If there's no complaint or no issue raised by the student, then we assume that the student are okay with the dates. So I already also saya dah bagi tahu kan test tu hari apa, minggu ke berapa? Ada inform kan? Ha. Nanti saya inform lagi sekali test tu hari apa. I already even book the dewan peperiksaan for that. I'm a person that prepare earlier so that is going awak boleh dapat the information as soon as possible to prepare yourself and to avoid this kind of issue lah. Bila saya prepare awal pun tetap ada isu macam ni dan ni lah sekarang ni it's up to you guys lah. Yeah. Test tu nanti, if I'm not mistaken, week 10. Nanti let me update in the WhatsApp group. I already even booked the Dewan Peperiksaan for test 2. Okay, so please for test 2 and final exam cannot. Now, final exam is already arranged. Is arranged by the academic office. So they already set the timetable accordingly. So we cannot do any adjustment. We just need to follow. But for test 1 and test 2, normally it's up to the lecturer to do the arrangement. So that's why if the lecturer kind of like did not aware that you are having 2 or 3 tests on the same day, please let the lecturer know. Okay? Jangan takut lah. Please let us know. Bukannya kita ni. This is not SPM, fixed time, fixed date yang awak kena buat pada hari tu juga. Kalau tak sit for the exam, you fail. Tak. Yeah? For the final exam, yes. But for the test, it's still negotiable. Okay? So, okay, we come back to our discussion. I don't know lah this ni. Okay, sample consisted of two component X and Y. Okay, so this is the process flow diagram that we need to draw if it is not provided in the question, including all the including all the information, including like this is the mass balance, this is the mass fraction. Mass fraction, mana yang the one that did not provide the value or the number, you can just put some question mark so that you are aware that these are the things that you need to find. Okay, something like this. Okay, so a simple process diagram like this is enough to give you clearer understanding about how to solve any kind of mass or energy balance. Start with this first. Okay, so like this one, sample consists of two components X and Y. Okay, the diagram already provided. Perform a degree of freedom analysis for the process diagram below. Okay, so I don't want you to, the question did not ask you to solve the material balance. Did not ask you to solve what is C, what is WX, WY, but just want you to perform a degree of freedom analysis for the process below. Okay, let's just try to solve the degree of freedom analysis. Okay, how to solve this? Okay, I think I just going to answer it here. D or F. Okay. What is to calculate and what is to minus? Okay, first of all, this is just a very basic thing about degree of freedom analysis. First, we need to know how many unknown variable. Unknown variable. Unknown variable is this lah. Benda ni ni. So in this case, how many unknown variable that we have? Anyone? 3. Metusa say 3. Any other answer? No. Okay. For this one, well, basically it's not 3. It's only 2. Why? It's already been explained in the video that I provided in my video of the lecture. Okay, in the lecture kan, I already provide another video explaining about the degree of freedom analysis. And one of the things that had been highlighted is that the fact that if the component is only two, yeah, for instance like this is x and y, we don't consider this as the unknown variable. This is because wy is equals, I really hate this. Wy is equals to w1 minus wx. So this is the same thing. We just need to know wx in order for us to solve wy. So this is not considered as the unknown variable if the component we have two like this. So that's why for this case, the unknown variable is only c and wx, only two. Okay, if you kind of like confused with my explanation, please go back and watch back the video about the degree of freedom analysis. Why only consider two and not three? But in case of, for example, we don't know the this value, b value, then the unknown variable will be 1, 2, and 3. But like this one, this already been provided. So the unknown variable is only 2. Please be careful, yeah. Please be careful with this and try to understand this. Okay. So now we already have the unknown variable of 2. How many, the other thing that we want to know is the component or the component lah. Component. How many component that we have in this process? How many component? Ini masuk test ni. Kalau awak tak boleh jawab sekarang ni, memang definitely you cannot answer the question in the test one. How many component that we have here?
2, Doctor.
2. Okay, good. X and Y, only 2. Okay, so is there any other equation? Other equation? Ada equation ni macam contohnya, okay. Ada equation ni contohnya macam A equals to C, let's say. I really, I really hope that you can understand my handwriting because I don't know what happened to my TED today because it's really did not working well. Hi. Okay, I just going to, okay. For instance, like if the question stated that A is equal to C. Okay. Oh, salah. Then, so this is, so this is considered as another equation that we have. So like this one, we don't have this. So we only, so we don't have any other equation. So the equation here is 0. Other equation is 0. So 2 minus 2 minus 0 is equals to 0. Okay. If the degree of freedom analysis 0, only then we can solve this problem. If we got -1 or -2 or -3 or 1 or 2 or 3, we cannot solve the the mass balance. So it is very important for you to see whether the degree of freedom analysis is equals to 0 or not before you proceed with the solving the question. Okay, I'm going to padam ni. What happened? Okay, I give you another scenario lah. What happened if you did not get 0 for degree of freedom analysis? But it's already stated in the question. Takkan nak tinggalkan kosong kan?
Set a basis.
Set a basis. Good. Okay. For instance, okay, ni 100 ni tak bagi. The question did not provide you with A value. So now we have the unknown variable of 1, 2, and 3. We have 3. So 3 minus 2 minus 0, we're going to get 1. 1 here. So 1 is undefined. We cannot solve the mass balance because the degree of freedom analysis is 1. So we need to put a basis. We need to do some assumption. As an engineer, you need to know when to do the assumption. Not all the time we can do assumption. There are few situation where we need to do some assumption in order for us to solve any kind of question. Okay, for this one, because the degree of freedom analysis is 1, we need to make sure that we want only 2 unknown variable here. So that's why if suddenly this case happen, maybe in the, I don't know, in the test ke ataupun tutorial lain ke, that the degree of freedom analysis is not 0, you need to set a basis. Normally we're going to set a basis with the first, the feed that come into the process. Okay. So what kind of value that we want to put? Normally just going to put 100 lah, because 100 is the easiest value that, when we want to do calculation. Okay. So what about the units? Okay. If there is no stated the unit, so you can just use SI unit or English unit. It's up to you. Yeah. But just be consistent for all the unit for the flow rate, for the mass flow rate. Okay, for the A is kg in hour, so C and B should be also kg per hour too. Okay, so just put a basis of 100. Yeah, like this. When you have the 100, so the unknown variable already changed to 2, and then we can solve the degree of freedom analysis is 0, so we can solve this equation, this mass balance. For this one, do you want to do because the question did not ask for us to solve the mass balance, but do you want to perform the, let's just do the ni lah, the second question lah, because I think it's also similar. Okay, but clear about the degree of freedom analysis and when but this is meant only for the basis for the basis mean for the normally for the single process only, but for the multiple process like this one, we have 2 or 3 processes in which we have to perform the degree of freedom analysis for filtration. Let's say for example this one, filtration 1, this is filtration 2, and also for the overall. So we have to perform 3 set of degree of freedom analysis. There will definitely be one of these 3 will be the degree of freedom analysis will be 0. So we're going to start with that. You cannot just say that, okay, because filtration 1, the degree of freedom analysis is not 0, so I going to do some assumption. No. The assumption normally will only mean for the single process in which you don't have any other processes to start. You need to start with this single process only. But you cannot start because the degree of freedom analysis is not 1. It's not 0. So that's why we do some assumption. We set a basis for this one. Okay, clear lah for this one? Okay, so now we move to the second question. A binary solution contains 20% salt and 80% water. The solution will need to be diluted so that the final salt content will be 8% only. Okay, so daripada 20%, we just need to have the final product of 8% only. Hence, the solution has been gone through a dilution process. Okay, the process is known as dilution with a stream of pure water. Determine the rate of the feed and diluting water needed to produce 2310 pound per minute of the final solution. Okay, so the first thing that you need to do now is to draw a process block diagram like this one, so that you can get the whole idea about how many processes, what go in, what go out, and so on. Okay, so for this one, the first thing you need to draw is the box lah. Okay, so this is a dilution process. You can just diluting process, but you can just process. Or okay, so the one that go in have 20% salt. So 20% salt. So the mass fraction will be. I think we just need to show you the solution. Let me just give you. Because I cannot write down using this. Okay, this is question 1. This is dilution process. Okay, this is for question 2. Okay, so this is the process block diagram. Dilution process. Okay, the feed that come in, there is no information about the flow rate of it. So we just put A here. But we know that the mass fraction of the water is 0.8, and the mass fraction of the it can be in W or in X, of the salt is 0.2. So this is for the feed. And then dilution process happen in which diluting water comes in. And it stated diluting water without any fraction of salt or water. So we assume that the water is 100% water lah. So B, diluting water, the flow rate also did not stated in the question. But one thing for sure, we know that the fraction of the water is 100%. So the mass fraction of water is 1.0. What about the salt? 0. Okay, good, Mutusa. Okay, because this pure water. Pure water no salt lah. Okay, so after the dilution process is go out as a product in which the product contain of 8% of salt. So the mass fraction of it is 0.08, while the remaining is water, 0.92. And we got the flow rate of the product that go out of the process, which is 2310 pound per minute. So now we need to find what is B and what is A. How much is B and how much is A? Okay. Do we need to do the degree of freedom analysis? Just do a simple one, so that we want to know whether this is a process that we can solve or not. Okay. So for based on this, how many unknown variables that we don't know? Okay, unknown variables. We have one here, A and B. Other already know, so we have 2. And how many component? We have 2, water and salt. So 2. Is there any other equation involved? No. So 2, 2. Okay, so we have 0. So this is the degree of freedom analysis for this one is 0. So we can solve this. So that's why we are going to start with the first balance, which is the overall balance. And the overall balance is consisted of the mass, the flow rate of the A plus B equals to C. We did not consider the component yet, just the overall balance. So from A plus B equals to C, we got this. Okay. We do some arrangement. So B is equals to 2310 minus A. And this is equation A, in which we are going to do some mathematical pairs in order for us to solve this later. Okay, for the component balance, okay, we can choose for the component balance whether we want to do the component balance for the salt or for the water. Okay, so I choose to solve by using the component balance of salt. Okay. So because okay, I explain later why I choose salt. Okay. So for this one, salt is 0.2 times A. So we don't know what is the value of A. And for B, there's no mass fraction of salt here. So we consider 0 times B. And then equals to 0.08. This is the salt times the flow rate of C. Okay. So when we do some rearrangement, so we're going to get A equals to 924 pound per minute. And then after we got this value A, we can insert A value in one back, so that we going to get B value of 1386 pound per minute. Okay, so this is very easy. Eh? Why I choose salt instead of water? We can solve this balance by using water component, the mass balance of water too. But in this case, I choose salt because we know that in the dilution water B stream, we know that salt is zero, so easy for us. This is considered B is zero, so it's directly we can calculate A. Otherwise, if we do the component balance of water, okay, so for water, I really hate this. Let me just type it. Okay, for water, I don't know why I cannot type in. Oh my God. Okay, water balance, Okay, for water is 0.8 A plus 1 times B equals to 0.92 C. Okay. So we need to do arrangement. So C is, we're just going to include the value 2310. Okay. So 0.8 A plus B equals to how many? 0.92 times 2310. 2125.2. Okay. So now we have to do some other quadratic equation rearrangement because we have A and B. Eh? Like the case like the if you just solve the salt, we already eliminate B here. So we straight away going to get A as the answer. Okay. But for if we choose water balance, then we have to. So this is considered as equation 2. So you need to do some arrangement. You need to include B here, the B for the is equation 1 into equation 2. Okay. Let us try to solve that. Okay, so we insert equation 1. So 0.8 A plus B, which is 2310 minus A equals to 21235 point 21235 betul ke? 2125.2. Okay. And then we do some calculation so that at the end we're going to get A rearrangement, so that A is equals to 924 pound per minute. Don't forget about the what? The unit, yeah? Okay. So the solution step is longer because we choose water balance instead of using sub balance. So it's you need to also strategize. But this is only case if there is a stream that consisted only one component in it. But if all the stream consisted of all the component, for instance, like this one, all the stream F, W, B are all have TS and liquid, so we cannot do this. We cannot strategize like this. Either way, we can just solve regardless whether you choose the longer step or the shorter step. The final answer will be the same. Okay, clear? Okay, so this is for question 2. Okay, so now we are going to solve question 3. In the concentration of orange juice, a fresh extracted and strained juice containing 10% solid is fed to a vacuum evaporator. Okay. In the vacuum evaporator, water is removed and the solid content increased from the previous 10% to 50%. For 500 pound per hour entering, calculate the amount of outlet stream and of the concentrated juice and the water evaporated in gram per second. Okay, draw and level a flowchart of this dry process. Okay, similarly, don't panic. Sometimes when you read the question, you kind of like confused. Wah, apa benda ni? But just take some time to draw the process diagram first, the block diagram first, so that when you draw the diagram, then you're going to get more understanding about the how to solve the question. Okay, so the block diagram for this one will be like this. Okay, so we have fresh juice. Okay, 500 pound per hour, and then we have the fraction of solid 0.1, the water 0.9. So it's undergo the vacuum evaporation process to remove the water. Okay, so this one is similar like question 2 also, because for the stream here, it's only consisted of one component, which is the water. We did not evaporate the solid. Only the water will be released out. And then after that, the final product, the concentrated orange juice, consisted of uh, 0.5 solid and 0.5 water. Okay, so from this question, when you draw something like this, you are going to get more understanding about the degree of freedom analysis, the understanding about what kind of value that you need to find. Okay, for instance, like this one, you need to find FB and FA. Okay. So similarly, you can do the degree of freedom analysis, but okay lah, we just calculate lah. How many unknown variables? 2. FB and FA. These are the two items that we want to find the answer. Okay. How many component? 2. Solid and water. So is there any other equation? No. So 2 minus 2 equals to 0. Okay, so this is the degree of freedom analysis for this one is this can be solved. Okay. So we start with the general balance first. Similarly, like the question in question 2, 500 equals to because this going out, not going in. So FA okay, terbalik pula ni. FA plus FB. Okay, so this is equation 1. And for this one, we are going to do the component balance. Okay. Which to choose? Which one that we should choose? Solid or water? Solid. Okay. Because we know that from solid we can have some shortcut, right? But if you choose water also, the final answer will be the same. Okay. So solid, we have like this. We just going to put all the details of the component. 500 times 0.1, FA 0.5, and FB times 0 because FB doesn't have any solid component. So at the end, we are going to get FA equals to 100 pound per hour. Okay, but the question asks in gram per second. So there's some unit of conversion unit involved. Okay, so this is also something that I also like to ask in my test and exam. Okay, I'm not going to just directly ask you in the unit, but I also want you to apply the unit conversion knowledge that you already learned in solving this kind of question. So from 100, just do the simple unit conversion approach. Pound we change to gram, and hour we change to second. So at the end, the final answer will be 12.6 gram per second. Okay, similarly, we still need to find FB here. 500 plus 100. Okay, please consistent with the unit because 500 is in pound per hour. So we consider the FA also in pound per hour too. So plus FB. So FB going to get 400. Also the 400, the question asked should be in gram per second. So we just going to do the direct conversion unit approach. So that at the end you're going to get FB equals to 50.399 gram per second. Okay. Similarly, I also give you example if you choose to do the water component instead of the solid. Okay, so for the water, like this, at the end, you're going to get FB is equals to 450 minus 0.5 FA. Okay, so we have equation 1, equation 2. So insert 2 into 1, okay, in order for you to get the final answer of FA equals to 100 pound per hour, and then you need to change the unit to gram per second. Okay. So far clear? I think mass balance is not that difficult if you understand the whole process. So the most important thing is to draw this broad diagram and then to do the degree of freedom analysis in order to see because the other step is just do the general balance and the component balance. Okay, now we are going to move to the multiple processes. Okay. A membrane separation system is used to concentrate total solid in pineapple juice from 10 to 30%. Okay, so concentration. The concentration is accomplished in two stages of filtration, with the first stage resulting the release of a low total solid liquid stream. The second stage of filtration separates the final concentration product P from a total low total solid stream, which is returned to the first stage filtration. Okay. So there are some stream that return back is like a recycle stream. Enter. The recycle R contain 2% TS, the stream B between filtration 1 and 2 contain 24%, blah, blah, blah. Okay, so include a degree of freedom analysis in your solution. Okay, for multiple processes, okay, there will be a lot of information will be provided. And if there's no diagram like this had been provided in the question, don't panic. Okay, please just start slowly drawing all the how many processes. Eh? Okay, sorry. Okay. So just draw one process to another like this one. But in this case, the question already provide with the what? The diagram. So it's easier for you. You don't have to draw it. Eh? Okay, so we have F. Okay, coming into filtration one. So this is filtration two. Okay, with 10% of total solid and 90% liquid. Okay, and this filter will filter liquid and the total liquid with some total solid. Eh? And then we from filtration one it will go to filtration two, and some part of the filtration two will be recycled back to filtration one, the one that contain a lots of liquid here. And then the final product will be the pineapple juice with 30% total solid with 70% liquid. Okay. So for instance, like this one, if the plot diagram have been provided, so it's easier because from here we just need to know what are the variables, what are the components that are missing that you want to do the solution. Okay. But first of all, when you want to solve any question related to the multiple processes, especially, you need to do the degree of freedom analysis. In fact, in the question already asked you about the degree of freedom analysis. So this is something you need to do. Okay, let's just see how we going to do. Okay, so we are going to have a three degree of freedom analysis. One is the overall that I draw in this blue border here. So when we consider the overall mass balance, the overall degree of freedom analysis of the mass balance is only involve F, W, and P, the one that go in and go out. For recycle, this is not going out from this border. So we don't consider R. Eh? So how many unknown variable here? We have W and we have P. We have two. How many component? Two. Any other equation? No. So let's just see. We have two, which is W and P, and we have component of total solid and liquid too, and we don't have any other equation. So the answer is 0. Okay, but it's okay. So we also perform the degree of freedom analysis for filter 1 and filter 2. Okay, let's just see filter 1 and filter 2. Okay, for filtration 1, how many unknown variable here? We have W1, we have B2, and R. So we have unknown variable, and in the same time, we only have two components, TS and liquid. So 3 minus 2 is equals to 1. So we cannot start our calculation from filtration 1. What about the filtration 2? We have the unknown variable B, R, and P. Okay, 3 also, and we have two components. So the degree of freedom analysis is equal to 1. So we cannot perform the degree of freedom analysis from filter 1 and filter 2. Hence, based on the degree of analysis, we should start from the overall system of mass balance. Okay, so let's just start with the overall system mass balance. F is equal to W plus P. Only these three, yeah? R is not related because this is not going out or going into the system. Okay, so the solution is like this. So F is equal to W plus P, just going to get just input the value that we have. So we have W equals to 310.5 minus P. So this is equation 1, okay? And then we are going to go for the component. For this one, because all the stream here contain two component. There's no stream that only have one component. So for this, if you ask me whether to choose solid or liquid as the component, you can have both. You can choose either one. Yeah, which one is up to you because there's no strategy for this. You can choose solid or you can choose to do the material balance of the liquid. The answer will be the same. Okay, for this one, I choose the total solid. So I do some arrangement. 0.1 times F is equal to 0.005 times W plus 0.3 times P. So at the end, we are going to get this equation 2. So similar like the quadratic, the simple quadratic solution, we're just going to insert 1 into 2. So 3105 equals to 005 W. Okay, this W we change to this. So 310.5, blah, blah. So at the end, you're going to get P as 100 kg. And then from here, you're going to go back to equation 1. We have F, you have P. So W is equals to 210.5 kg per minute. Okay. So is there any even the question did not ask you to change the unit, right? Okay, so just so the final answer will be like this lah, kg per minute. Okay, and then we still need to find the solution for, we already have P and W. We have W and P, but we still need to find the B and R. So we need to do another balance. And now we are going to proceed with filter 1 mass balance. Okay. Question here. Where to start? Whether filter 1 or filter 2? After we do, we start with overall first, right? Overall mass balance, overall system mass balance. And then after we got this value, what which one that you're going to start next? Can we start with filter 2 or should we start with filter 1? We need to go back to the degree of freedom analysis to see. For instance, okay, here we have value of P and W. So we are going to go for filter 1. So we have the P and we have W and P. So W here already known the variable. So this is 2 now. So 2 minus 2 is equals to 0. So with the new info that we got after we do the calculation for the overall system mass balance, filter 1 degree of freedom analysis is already 0. What about filter 2? Okay, for filter 2, B is still, we don't know. B, P we know, R we don't know. Similarly, this is 2, 2. So 2 minus 2 is equals to 0. Okay, so in this case, we can start the next calculation based on filter 1 or filter 2. Okay, because both of the this process, after we do the degree of freedom analysis, after we completed this part, already the degree of freedom analysis already resulted 0 value. So that's why either filter 1 or filter 2 for you to start, you can start. Yeah. But if you have filter 2, but the degree of freedom is still 1, for instance, like I give you another example. Filter 1, the degree of freedom is 0. Filter 2, degree of freedom, after do the calculation, then the latest one is still 1. Then we need to start with the process that have the degree of freedom analysis equals to 0. But for this case, both processes already 0, so we can start in filter 1 or filter 2. Okay, so I just use filter 1. Just use the general balance first. The general the general balance for filter 1, okay, is F and R, yeah. This is the input. Okay, R is also going in the filtration 1. So F plus R is equals to W plus B. F plus R is equals to W plus B. Okay, so after rearrangement, we have equation 3 here. And then for component also, you can choose water or total solid, but I just choose total solid here. Just include all the value at the end. You are going to get something like this. This is equation 4. Similarly, what you need to do so is set 3 into 4 so that you are going to solve the question one by one. So at the end, you are going to get R value of 21.74 kg per minute. And then after that, you can solve the V value of 121.74 kg per minute. Okay, so I also give example if you solve the question by using filter 2. Similarly, for questions 2, is B equals to R plus P. Okay, R is going out from filtration 2, right? So B is equal to R plus P. So this is the value. You can just do the same step for the general balance, and then we have the component balance, total solid, and then you do the arrangement so that 5 can be inserted into 6, and then you're going to get the value of R and then B. Okay, I think more or less the flow to solve any kind of balance is the same. It's just a matter for you to understand the question and draw the flow diagram, the block diagram, and do the degree of freedom analysis in order for you to solve it. In terms of the calculation, I don't think it's really that tough. Okay, so he already solved question 3, question 1 for the multiple processes. Okay, so we are going to continue with question 2, multiple processor. A concentrated fruit juice containing 95% solid is diluted by adding water. Okay, concentrated juice 100 kg. Okay, afterward, the fruit juice is filtered to remove 50% of the initial total solid content. Okay, so this is only and then diluted with all pure water. For 100 kg of fruit juice containing this process, how much water in pound per second must be added so that the coming out from the process, the final fruit juice contain only 5%. Okay, the final 5% fruit filtered juice. Okay. And what is the filtered juice flow rate coming out? What is the filtered coming out from the process in pound? Okay. So it's given you in kg per hour. At the end, they want you to solve it in pound per second. Calculate also the diluted juice flow rate. Okay, what is the flow rate here, flow rate here, and its solid content. Include a degree of freedom analysis in solution step. Okay, for this one, question 2, the diagram already been provided, but it's not completed because it's not as complete as this one. So I would encourage you, if you got something like this, please draw back the plot diagram and include all the information. For example, like this is 100 kg, and then the solid content is 95%. Okay, so just going to show. Okay, so if the block diagram is not completed, so you need to draw back with all the information. So the concentrated juice kit, we're just going to put M1. Okay, the water is M2, M3, M4, and M5. Okay. Okay, with 100 kg per hour, the fraction of the solid is 0.95. The water is 0.05. And then for water, pure water that go in, of course, it's water, so no solid 0, and water is 1. And then the diluted juice, M3, we don't know. XS and XW, we don't know. Okay. And then for the solid matter, they go out of the filtration, M4. When the solid matter, that means it's solid, 100% solid. So there's no water. And then M5, which is the filtered juice, XS is 0.05 and water is 0.95. Okay. So after you completed all the information in this diagram, then we can perform the degree of freedom analysis. We are going to start with the overall first, the overall system. Okay, so the overall will be something like this. So we consider M1, M2, M4, and M5. M3 is not considered in the overall system by considering that it is not going in or going out of the boundary here. Okay, so how many unknown variable? Yeah, we have M1 1, M2 2, M5 3, and M4 4. Sorry, M1 we already have the value. Sorry, so M2, M4, and M5 we have 3, and then we have how many components? We have 2. XS and XW, solid and water. And other equation, so let's go back to this. Hold on per second. M4. Okay, hold on. %. How much water? Okay. The final fruit juice contain 5%. I don't know where I get this another one equation here. Oh, okay. Sorry. N4, which is the oh, okay. So the other equation had been stated in the first two sentences here. Okay. A concentrated fruit juice containing 95% solid is diluted by adding water. Afterward, the fruit is filtered to remove 50% of the initial total solid content of the feed. Okay. So it's just going to say that here the feed, let's say the feed 100 kg feed, 100 1000 kg feed that contain 95% solid. So the solid content in this 1000 kg per hour juice is 95%, is 950. So for this one, so that's why you need to read the question really carefully. Otherwise, you will be missing some of the information. So this is 900 kg solid. So afterward, the fruit is filtered to remove 50%. Okay, filtered, remove 50% of the initial solid content. Okay, here, the solid content is only 50% from the solid content that we have at the very beginning. So, it's 50% of 650 kg solid. Okay. That means that this is 450. 475 kg solid that is removed from filtration here. Okay, so this is the equation. This is actually a link that we need to also consider in the degree of freedom analysis. Okay. So that's why you need to read the question carefully in order for you to perform the degree of freedom analysis. So that's why the another equation which is something related to here and here. So we have another question here. So the degree of freedom analysis 3 minus 2 minus 1 is equal to 0. And for the dilution, we have unknown variables of M2 and also M3 and XS. Okay, XW is not considered as the unknown variable because it's just 1 minus XS. So we have 3 and then the component is 2, but we don't have any other equation. As for the filtration process, we want to know M3, XS, M4, M5. We have 4 unknown variable and we only have 2 components without any unknown variables, other equation, sorry. So because this is only referring to the filtration process, the one that 0.5% of the total solid, this equation is only mean for the feed and M1 and M4, but in the filtration process, it's not related to M1. So that's why we don't consider the equation here. We only consider equation in the overall system mass balance. So based on the degree of freedom analysis, we should start with the overall system of mass balance. Okay. So in the same time, we are going to start with the first thing, which is the equation, as I show you. 0.95, 95% of the 1000 kg per minute in the feed. This is the feed. Uh, okay, this is 455 eh. Okay, sorry. 455 kah? 475. Sorry. So there's a mistake with the calculation here. Okay. This is 7. 475. Okay, so we know now um the M4 is 475 kg per minute per hour. Because it's consistent. Why? Because we are okay, 47. I don't know what happened to this. Okay, it's okay lah. But because there is 100% solid, so we assume that the mass flow rate is also the same lah. Kg 475 kg per hour. Okay, so we solve M4. So with all the equation that we have here, we are going to start with the overall system, the general one, which is equals to M1 plus M2 equals to M4 plus M5. M1 plus M2 is equal to M4 plus M5. So we have the value of M1 and M4 already. So we are going to do arrangement so that we're going to get the 5 to 5 equals to M5 minus M4. This is the first equation. Okay. So that after that, we are going to proceed with the solid because here we have the water. Oh, okay. So here we have water 0. So 1000 times 0.95 plus M2 times 0 because it's only pure water. And then, okay, at the end, we're going to get M5 is equal to 9500 kg per hour. But the question asks in pound per second, so we need to do some unit conversion. So the final answer will be 5.82 pound per second. Okay, so we already solved N4 and M5. We still have M3 that we want to solve. Sorry, M2 also. Okay. So we have M5 and then we can get M2 here, M5. So M2, we're going to get 8,975 kg per hour, which can be converted to pound per second. So this is the answer for M2 and M5. So we have M4, M2, and M5. The only M that we still did not get is the M3. So after that, we need to move to the next process to do the balance. Uh, so again, we just referring back to the degree of freedom analysis, and based on the info that we have, we can proceed with the dilution process because here is already 2. So this is 0. So just do the general, we are going to get the 1,000 plus this is for the dilution. We have M1, M2 is equal to M3. M1, M2 is equal to M3. So M3 is 9975 per kg. And then this is the answer in gram per minute because the question for M3 is asked in gram per minute. Okay, this is gram per minute. Okay. And then the fraction, okay, for solid. Okay, here the fraction here also need to be solved. So we do the solid balance under the dilution process. At the end, we're going to get XS equals to 0.095. So we have already answered all the question. Then we got all the unknown variable here. So that's about it. For the multiple processes, basically the solution will be a bit longer because we have to do a balance of the process, once process to another process, move one slowly one to the other one. So, but the most important thing is to read the question carefully, draw the diagram, and then make sure that you did not uh, miss some other information that can be considered as other equation, for instance like this one. Okay. Okay, so that's about it about the solution for the tutorial. Okay, so we already completed the tutorial 4 related to mass balance. Definitely there will be question related to mass balance, single and multiple processes that will be asked in test 1. So I really hope that you are going to prepare for test 1 and try to do the revision. Okay, I think it's easier now by considering all of the thing that we share had been recorded. So if you don't understand a thing about any specific topic, you can just go back and listen back to my lecture notes and also to the tutorial video in order for you to solve to understand, to get more understanding. But in the same time, please, I would like to encourage you to uh to do a lots of other examples and exercises so that you're going to be more familiar with how to solve any kind of related question. Okay? Any question for this one? Any question related to mass and energy balance? No question. Okay. So I think that's the end of our tutorial today. I wish you all the best for your test 1. Please do revision for test 1. The level, the question for test 1, I would say just average lah. Just moderate. It's not really that difficult, but it require you to answer it carefully so that you're not going to do any silly mistake. The unit conversion table will be provided, but all the simple formula related to temperature, related to pressure, related to chemical composition, there's something that you need to memorize lah. Yeah. What else? And we already completed the part of the mass balance. Next week we are going to have test 1, and then I will decide on. Do you have any other tests on Thursday next week? Hmm? Test the last test hari apa?
Friday, Doctor.
Friday. Oh, you still have on Friday. Friday tu online ke apa?
Yes, online, Doctor.
Okay, okay, tak apalah kalau online. Okay, so maybe on Thursday we are going to discuss about the test one punya answer. But let me think about it. I will inform you. But again, ni lah, just prepare for the test lah. Any final question for everyone? No question. Okay, so that's the end of our class today. Just prepare and don't forget to submit the exercise for week 4 and also tutorial 3. And also please do tutorial 4 as well as what been discussed today because you need to also prepare yourself for the test. Okay. Okay. Thank you so much. Okay. Bye bye. Selamat berbuka. Assalamualaikum.